My previous video mentioned not at all about the whole subject of carbon dioxide in the air and its potential influence on climate change. And today what I want to do is explore that issue with you in some detail. Here is the graph that we were looking at the last time that shows the temperature map for the world from data that's actually not from 1840 to 2020, but actually from something like 1850 through the current 2014, I presume, and 2015 will be added as soon as that data comes available. And if you remember what I was doing in the previous video, I basically took this video graph and tried adding various curves with a particular emphasis on this period of time between 1958 and 2014 or 2015. And I discussed the problem that was going to be created by virtue of the fact that the data appears to no longer continue to rise continuously as it did prior to about the year 2000. And you can see that right here. Now, the place I want to take you today is what would happen if we replaced our simple time trend variable with a carbon dioxide variable. And you need to be aware of the fact that the primary source for carbon dioxide data all comes off of a site in Mauna Loa, Hawaii, that's actually near a volcano. We can look at that data quite easily on the web. Here is the temperature data on the web. Here is the carbon dioxide data from 1958 up through 2014. And as you can see, that data is quite linear. There's a little bit of variation within the year that we see in terms of the fluctuations of the line, but in general, the line continues upward. And if we take that fluctuation out, we would get a line that looks like this. Almost a linear trend line, but seemingly increasing at a little bit of an increasing rate. What's going to happen then, if in fact we replace the time trend variable with the carbon dioxide variable, everything will once again look reasonably okay from this period 1958 through 2000. I suppose we could actually do that here. Let me throw in a curvilinear line here and see where that gets us. Be nice to have a little bit different color going on here, so let me fix that. Let me make that a green line since I don't have any green lines here, and then let me see if I can put a little bit of an increasing trend there. And as an econometrician, that actually looks pretty good. The problem that I get into, however, is how do I cope with this data that now appears to have flattened out when in fact I look at the carbon dioxide data in either its raw form or its trended form, and there is no flattening whatsoever. Well, there could be several possible explanations for this, and I want to work through with you what some of these possibilities could be today. The first possibility is that the Mauna Loa carbon dioxide data may not accurately reflect the true worldwide average carbon dioxide levels, and if we had a better measure that took into account many more locations, we might end up with some carbon dioxide data that looks much more similar to the data that we see for temperature. In other words, a better measure might actually incorporate that flattening that we're seeing. But this in itself is problematic because this basically would say then that the fossil fuel burning that's causing the rise in the carbon dioxide is not really doing what it had been doing prior to approximately the year 2000. Now, if you read the critics of the climate change science, what you'll discover is that they're making this second argument, that carbon dioxide is actually measured in parts per million, and even substantial increases in the burning of fossil fuels might not have that much impact on global warming. Well, that's an interesting argument, I think, and one that certainly deserves some effort in terms of looking at it from the standpoint of science. How much of an increase do you have in a gas that represents, even under increased amounts, still just a trivial part of the atmosphere relative to the roles that nitrogen and oxygen and things like that play in terms of changing the global warming pattern? A good research question in my mind. Then the third idea that's floating around is that other yet to be identified factors may be the primary driving force in determining global temperatures. In other words, maybe, just maybe, all of this so-called settled science about the role of fossil fuel burning and carbon dioxide is not quite as settled as many of the climate scientists would like to believe. And I would like to think of this as being a situation where this is very much the work for an econometrician to sort out, just as much as it is for a climate scientist. What variables mimic the intertemporal patterns that we observe in global surface temperatures more accurately than either a simple time trend variable or a carbon dioxide measure out of Mauna Loa? This is, in my mind, a very basic research question that hasn't been adequately addressed. Then the next question that comes to mind is, what role do plants play in all of this? Could it be that the air over an area with large amounts of plant growth is commonly lower in carbon dioxide than, say, a desert area? And what about the differences between the carbon dioxide content of the air over a cornfield, which is quite a big plant, versus a soybean field, which is a smaller plant? Or make a comparison between the air over a pasture versus a field crop. It seems to me that if you're going to trust this Mauna Loa data to accurately reflect the carbon dioxide levels worldwide, at least the evidence has got to be brought to bear that the numbers for carbon dioxide over a green area, where plants are taking in carbon dioxide and releasing oxygen, might be different from a area where you have basically desert and there's none of this plant interaction with carbon dioxide. Good research questions in my mind. Let me explain this further. The physiology of all plants means that they are taking up carbon dioxide while releasing oxygen. They are nature's natural carbon dioxide sequestration mechanism. If we could better understand how this works around the world, perhaps we'd better understand why global temperatures have been rising so erratically year over year, with these occasional lengthy periods, at least from the period 2000 to 2014, where global temperatures appear to be stable in the face of rapidly rising carbon dioxide levels, at least the carbon dioxide levels measured at Mauna Loa. Other as yet unidentified factors that contribute to climate change that have nothing to do with the burning of fossil fuels could be the culprit. But of course, if we've already accepted the notion that fossil fuels are the cause of the carbon dioxide rise, which is one leap, and then the second notion that it's the carbon dioxide rise primarily, if not exclusively, that's causing the rise in global surface temperatures, these are not researchable questions because they've already been settled. Can we really honestly and with a straight face say all of this is settled science and that there is no need for further debate or research? Think about that. Think about that.